This video is on the objective, find the sample size required to estimate a population mean with a given confidence level. And this is number 1. This is the first video I'm making on a question related to this objective in your Newton Alta homework. So again, if you're looking at this objective here and you're unfamiliar with what it's saying, you want to learn more about it, click on More Instruction and read the notes, watch the videos, and look at the examples they have there. Maybe that'll help you. And I'm also hoping, of course, that you have read section 8.1 in your OpenStax statistics textbook. Alright, so here. Suppose the scores of a standardized test are normally distributed. If the population's standard deviation is 3 points, right? So that's sigma. What minimum sample size is needed to be 90% confident that the sample mean is within 2 points of the true population mean? Alright, so I'm going to draw some pictures here. I'm going to take you to a piece of paper and we'll talk about all this. Over the calculator. Alright, so we have our population. We have this population of all test scores, right? All standardized test scores for all students. That's the population. And let's say variable x represents these test scores. Now we're told that the population's standard deviation is 3 points. Right? What we don't know is the population mean. Right? We don't know mu, the average test score for the entire population. Right? This is unknown, and when this is happening, right, when we have an unknown population mean, we'll make a guess as to what that is using a sample. And that guess is called a confidence interval. Right, we're going to be a certain percentage confident that the value of mu, the population mean, the average of all test scores, is within a certain range. So remember what happens here is now from this population a sample is taken. Pardon me. All right, a sample of size n is taken, and then we take the average. Right, x bar would be the average test score, the mean test score of these n people. Right, of any group of n people. Now, by the central limit theorem, right, by the CLT, the central limit theorem for means. Now, since they told us, right, the population was normally distributed, right, with a mean of mu that I don't know and a standard deviation of 3. Since the population was normally distributed, then the distribution of these means, right, the averages for samples of size n, will also be normally distributed, right, with a mean of mu sub x bar and a standard deviation of sigma x bar. And the mean the mean of the means is that mean of the population, which again is unknown. So we would use our sample mean as a point estimate. Hopefully this is all familiar from an earlier video on creating a confidence interval. And the standard deviation, right, of the sample means of these x bars was the standard deviation of the population divided by the square root of the sample size. And this is known, the only thing I don't know is the sample sizes here. That was not mentioned. That's what we're trying to figure out. Right. And then I can draw a little picture. So here's a number line representing different possible values of the sample means, different possible values of x bar. And it's, x bar is normally distributed. So I got a nice, smooth, symmetrical bell shape there. And then under the peak would go our point estimate, the x bar, our sample mean. Sorry that this is really tiny here. This says sample mean. And then what we'd be looking for, we're asked to create what's called a 90% confidence interval. They said, we have a 90% confidence level. They're saying create a 90% confidence interval. All right, so what that meant was that from my sample mean here, I went so many standard deviations to the right, went to some value over here. That's x bar plus, the margin of error. Remember ME for the margin of error. I went the margin of error above the middle, and then that same distance below the middle, that's x bar minus the margin of error. I had to figure out what this error needed to be so that the area underneath the curve was my confidence level, right? So that the area under the curve was 90%. Now remember the margin of error. Here's a formula that you'll have seen by this point. Remember this margin of error, is just a certain number of standard deviations. So recall that the margin of error is, some z-score. And it would be the z-score with a certain percentage above it. What we're trying to do here is find the z-scores of these values, the x bar plus the margin of error and the x bar minus the margin of error. Now if there's 90% between them, that means there's 5% above this value and 5% below this value, right, to make a total of 100. So we would be looking for the z-score with 5% above it, right? Remember that was those z-scores with the subscripts, z with a subscript of 0.05. Right? Remember when you saw this stuff, z with a subscript of alpha over 2 or half alpha. We'll talk about alpha later, but remember this was just the z-score with alpha over 2 above, right, above it, alpha over 2 area above it. So I'm, whatever the z-score of this is, standard deviation. So I'm this many, right, z 0.5, 0.05, I'm this many standard deviations. Now what was the standard deviation of this? It was this thing here, times, sigma over the square root of n. So here was a nice little formula to help us calculate, the margin of error. Now, in this particular problem, we know all these values except n. Right? We know we're asked for, I go back to the website, back to the problem, we're asked to have a margin of error of 2 points. Right? We want to create a confidence interval such that the sample mean is within 2 points of the true population mean. So that within 2 points, remember that's like give or take. That's the margin of error here. I know sigma is 3. I know the margin of error I wish for is 2. And then here I've got that z, what is that z-score with 5% above it? That's 1.645 standard deviations. So I've got everything I need here Going back to the paper. So again, I know sigma is 3. We would like, or we're asked for, a margin of error of 2 points. So I'll put in 2 for the margin of error. Z 0.05 we can find from the table, right? From the table that's provided here is 1.645. And all that means is that this value, right, this upper value and this lower value of the confidence interval are 1.645 standard deviations above and below the mean. Then we just solve for n, because I can plug all this stuff in, right? So we have 2 on the left side equals, and then the z-score is 1.645, right? That z with the 5% above it, times 3 for the sigma divided by the square root of n. All right, now 3 times, again, really, if I take this formula here and solve for n, you can multiply by the square root of n, divide by the margin of error, and then square both sides. You'd have n equals, the z-score times sigma divided by the margin of error, and then all of that squared. All right, so that's what I'm going to end up with here. We're going to see n equals the z-score, 1.645, times sigma times 3, divided by the margin of error we wish for, 2, and then square all that, right? Because the n's instead of the square root, you want to get rid of the square root. All right, so I'm going to punch this in, pull up my calculator. All right, so we take 1.645 times 3, then divide that by 2, and we will square this number afterwards. So this is equal to, 6.08 something. But remember, n is a sample size. N is a sample size, and you always bump it up, because the larger the sample size, the smaller the margin of error. So if we took 6.8 people, which you can't do, you'd have a margin of error of exactly 2. And if you bump it up to 7, then you'd have a margin of error a little less than 2. But that way at least your upper and lower bound are within 2 units of the middle. So always bump it up. Always bump it up. So we're going to use n equals 7. So this is the minimum sample size needed to ensure a margin of error of 2 or less in my confidence interval, in my 90% confidence interval. I'll just put CI for confidence interval. All right, so if I took a sample of size, 7 or more, 7 people, 8 people, 9 people, whatever, test scores, took their average and created this whole confidence interval thing, 90%, what value above and below gives me 90% below the air, under the curve. If this size is 7 people or greater, then my 90% confidence interval will have a margin of error of 2 or less. Right? This value of here will be 2 or less. Okay. Right, so back here, this says enter your answer below. Again, be sure, they tell you, right, be sure to round up to the next integer. It was 7. So I need 7 test scores or more. Right? That 7 test scores or more are needed to be 90% confident that the sample mean will be within 2 points of the true population mean. And submit. Great. And again, read through the answer explanations when you're right, when you're wrong. And I see how that is squared everything here. I like doing the z times sigma divided by margin of error and then squaring it, but That way I don't have to hit the square button 3 times. And again, they got that z-score with 5% above it. Right? The z-score of the upper value in the confidence interval. So yeah, read through all this, especially if you're wrong, right? Especially if you're wrong, read through the answer explanations, see where, if you can figure out where you went wrong, and if you can't, maybe send it to me, send me a question about it. All right, so hopefully this helps you out when you're working on this kind of a problem on your own. And I'll have another one probably about problems similar to this after. All right, and thank you very much for watching.